this question says 2, 2 square, 2 cube, so on till 2 to the power of n. It's 2 to the power of n plus 1 minus 2 holds for all the natural numbers by induction. We need to prove this. Let's start. So for the proof, what is your step 1? Step 1 is put n is equal to 1 on LHS. What you're gonna get? Just 2, 2 to the power of 1, right? On RHS, 2 to the power of 1 plus 1 minus 2, right? So 2 to the power of 2 minus 2. So that's just 2, right? Because 2 square is 4. 4 minus 2. So can we see n is equal to 1 is true. Okay. Next, go to the step 2. Step 2 is assume n is equal to k wholes. So what do you get? 2, 4, 8, so on till 2 to the power of k is 2 to the power of k plus 1 minus 2. Let's label this as star. Okay, I've just subbed in, wherever the n is there, I have just subbed in k. Now let's do the step 3. We will prove step 3. Prove that n is equal to k plus 1 wholes. If that's there, then what do you get? 2, 4, 8, so on, 2 to the power of k, 2 to the power of k plus 1 is equal to minus 2. We need to prove this. Let's start from LHS. And this writing this line is mandatory. You're declaring what you want to prove. It's mandatory, else you will lose your points. Now let's focus on LHS. So 2, 4, 8, so on, 2 to the power of k, 2 to the power of k plus 1. You have this, right? Now till k, can I pick it from star? What is its value? 2 to the power of k plus 1 minus 2 plus 2 to the power of k plus 1. Just have a look. You have 2 to the power of k plus 1, 2 to the power of k plus 1. So these two terms are there, right? So just think it of a variable. 1 times x plus 1 times x. It will be 2x. So similarly, so this will become 2 times 2 to the power. It means I'm having 2 of these kind of terms minus 2. But can I write 2 as 2 to the power of 1 times 2 to the power of k plus 1 minus 2? So it becomes 2 to the power of k plus 2 minus 2, and this is your rough work, the dry work. Okay. So what we can say, therefore, n is equal to k plus 1 is true. If n is equal to k plus 1 is true, so what we can say, therefore, or this gives us by mathematical induction, by given statement holds for all natural number n. Okay, so given statement holds. So this is the proof